So clock math and check digits. We'll start with an example just to kind of get started here. We have a secret meeting in 50 hours. It's 2100 military time, which is 9 o'clock p.m. military time. What time do we meet our contact? So, you could do this a long way, and this is not the way we're going to do this problem, just a heads up. But if we really kind of try to think about this and just count it out 50 hours from 9 o'clock p.m. in military time, 9 o'clock is 2100, so I just made it short as 21. And then we could go ahead and count. There would be 3 hours left in that day. And then the next day, you could get a little bit savvy and be like, well, there's 24 hours a day. And so then that would get me through that whole day, and then I got to start counting the next day to get up to my 50. And so it goes through the rest of that one day, another whole day for the next day, and then almost through another entire day to get through to 2300 hours. And so notice that in the question it just says what time, it doesn't say what day, and so we could just answer 2300, which would be 11 o'clock p.m. So a shortcut for this is, notice that we went through a couple cycles of 24 hours. And so if you look at your note sheet now, there's a formula that I made for you. And this is not a unique formula. There's a lot of different formulas we could use as a shortcut. And these are not in order, so make sure you kind of look down about 3 sections down to where it says military time. A shortcut for this is we could use this formula, which plugging in the stuff we have, the number of hours that we wanted to go into the future was 50, so that's what you'd plug in. You guys see where I am, like the 50 here? You plug that in times 100, because the military time we just put it as like a whole number and don't have the colon part, so that makes it put it into like that military time with the hundreds, the times 100. And so you do that part, and then you add that to the present military time and take it, and it says mod 2400. So the mod 2400 is like, take out the cycles of 2400 hours. That's what you can think of that as meaning. So we do some division here when, after doing this calculation out front, that's in the parentheses, we get 7100. If that number is greater than the mod whatever part, the 2400, then that's like, hey, there's some cycles of 2400 in here that I want to take out, and I just want to know what the remainder is. Like, where are we in that day? And so you can think of that mod part as meaning taking out the cycles of that length. And so we do some long division here where we're trying to get at the remainder, and we've already been doing this when we've been converting number systems, going back from something that's not in base 10 to get back to base 10. So same kind of thing there, where we take 2400 going into 7100. It goes in 2 times, so there's 2 cycles of 2400 is what that means. But actually all we care about is the remainder. So the remainder here is 2300, and that's the answer to our problem. So going back to that long example, this was not terrible because it's 50 hours, but if you can imagine, it was like 5,000 hours. You definitely want to do it this way, and that's kind of the reasoning you would do to solve a problem like that, is you would say, well, how many cycles of 24 are in here? So the way it was organized here, if you notice that in the first day you had 3, and then in the last day you had 23 hours, that if you combine those actually had another cycle of 24 out. And so there was 2 hours difference with the start time and the end time. And so this, again, this formula could be made in a lot of ways, but kind of the way it was designed is taking that initial time plus the remainder of the hours, or the 2 hours, to get the 2300. So let's do an example where we're not trying to do it the long way and understand. So, and just use a formula which is provided on the formula sheet for the test, so let's just do it that way. Right now it's 9:05 military time. What time is it 128 hours from now? So using the formula sheet, the future military time, and then we have this formula, present military time plus the number of hours times 100, and then take that all mod 2400. So the future military time with our stuff plugged in was 9:05 plus the number of hours is 128. You got to take that times 100 and then take that mod 2400. So we have this new operation of the mod part. For our purposes, just do like everything out front first and it'll work every time. And you can see that they're in these brackets and parentheses and stuff, so that's probably what you'd tend to do anyway. So we do the multiplication first, and we get 12,800. Then go ahead and take 9:05 plus 12,800. And we get 13,705 mod 2400. So now you can think of that mod 24 as meaning what's the remainder after I take out the cycles of 2400. So to do that, 13,000 whatever is way bigger than 2,000 whatever, so definitely there's some cycles of 2,400 in there that can be taken out. So the mod whatever part is the divisor. And if you want, you can use your calculator to get started here, or just do this all by hand. If you estimate, you should find, or in your calculator you should find either way, that 2,400 goes in 5 times. So 5 times 2,400 is 12,000. We just subtract this to get the remainder, 1,705, and that's the answer to this problem. So for this problem, we don't care about how many times it goes in, the 5 part of this answer, we just care about the remainder. And I guess it doesn't matter, but usually military time you don't write the comma with 1,000, so it's 1,705 hours. So what time is that, just to practice, what time is that in PM? Yep, 5:05 PM. You can just leave it in military time. Okay, so any questions about that one? Okay, take a look at your assignment. It actually starts out with some basic problems. I just wanted to go over a little bit of the motivation on why we're doing these weird math problems that has that mod word in it. And so we'll get to more applications, but now let's backtrack actually and just kind of practice this mod thing. So there's 3 cases of having something mod something on this assignment, and we're going to go over another example later once we need it. For now we don't need it. So first thing is do the parentheses first, so this is going to turn into 14 mod 11. And so this one's very similar to the example we did in the sense that 14 has at least one cycle of 11 in it because it's greater than 11. And so we want to think of doing the long division, where 14 goes in the box, And this one's easier than the one we did. 11 goes into 14 how many times? Once. And then we do this to get the remainder. 14 minus 11 is 3. So what's the answer to this problem? Like kind of our choices are 1 or 3. 3. All we care about is the remainder. So you can think of mod, that mod thing being like, what's the answer to the long division problem with the remainder? And then we don't care how many times it goes in, or we don't care how many cycles of 11 goes through. All we care about is where it is in the cycle of 11 on its last round through. So the answer to this is 3. Okay, let's look at another situation. 1 plus 3 in parentheses mod 10. So what do we do first? Yeah, and so we get 4 mod 10. Now think of this as the same interpretation as the one before. Where are we in a cycle of 10 when we're at 4? And I bet you can get the answer. Well, think about it. So if you're in a cycle of 10, you know, like, and you're 4 in, it's just 4. So if the number is less than what we call the modulus, or the second number, then this is really easy. It's just already the answer. So if you're 4 along in a cycle of 10, then you're 4 along in the cycle of 10, and then you just state what that number is. So I haven't been very good about annotating here. I've been saying it in words, but let's backtrack to part A. The reasoning here was if this number is greater than or equal to the modulus, which I'll just say this number and point to it, then it's the remainder after long division. And you can see the specific long division we did. Our decision process in part B was that this number was less than the modulus. Then the answer is the first, I'll just call it the first number. Which was 4 in this case. And again, the reasoning was we're already in that first cycle of 10. So questions on those? Okay, let's do this last one. So we go ahead and do the parentheses first. 79 plus 2 is 81. And we're going to use that same reasoning. Where are we in a cycle of 9 when we have 81? And because that number is greater than, we do the long division. So how many times does 9 go into 81? So let's think about it. It's like kind of a common answer. 9 times what equals 81? 9. Good, okay. So then, what is the answer to this? 0. That's right. So we use that same steps as we did in part A. What does this mean? This means we're at the start of the cycle. And we call the start of the cycle 0. Instead of being at like a location 1, we call it 0 for things to kind of work out well with this division and stuff. So this, when you get 0 for an answer, that means that you're at the start of the cycle. Of the modulus, which in this case is 9. So I drew a little picture down here to kind of illustrate what I was just talking about. On our clock, we're calling this clock math, we label, instead of labeling the start 0, we label it 12.